Okay, we are live. Thank you, everyone who is tuning in already. Um, here with Diego and Mauro. RJ will be joining in a little, but we figured we can get things started and jump into some updates. And yeah, I think Diego and Mauro have some things to discuss today. Some new things, cryptography related. I'm excited to hear about. So yeah, how are you guys?
All good, Boris. Happy to be here talking with you. We miss a bit RJ, but he will be soon. But still, we have like lots of interesting things to talk about. I think that um, I just opened X and saw that one team um, released a statement on a bug they had on their VM.
Oh,
So I think this shows why um, it's important to continue working on security, doing lots of audits, and trying to have as simple VMs as possible, because then you can start having like lots of uh, very subtle bugs. Uh, and then I think we will have to update a little bit the version of the VM and everything.
okay.
Oh, RJ. No,
Oh,
RJ
we
is
have some
someday in the future.
with some fancy curtains. Or
Yes, fancy, or they look like from Black Ops Zombies mode.
well, that's my kind of fancy. I grew up with that, you know.
Yes, me too. Yeah, that is fancy. It's true. Royalty.
Yeah. Well, we could say now that the sun doesn't set on this team.
Align. Yeah.
No, no, I'm living. I'm living like my days are. I don't know how to explain. Like I have 2 days in one now instead of having one.
So for those
Um,
who don't
I,
know, like Earthshade travel for like 40 hours or close to that, and is
yeah,
in the other corner of the world and suffering shellac. Uh,
yeah. I need to live like two days in one so I can catch up with everyone. So that's why I'm a little late.
RJ, you're on the Uberman schedule. Have you heard of this? Where you sleep, you know,
No, I didn't know this.
you sleep like four, like 3 hours, and then you have like you basically have two small sleeps, so you have two
Mm,
days with more time. But
it's
people
literally that.
like they'll have four, 2 hour naps, and then be awake the rest of the time.
Making 8 dates out of 7.
Yeah. Anyway,
Yeah,
okay.
so sorry I'm late. Um, but it's good to see everyone.
It's like that. While you are grinding like 5 days a week or 7 days a week, Hershey is having like 8 days a week of work.
this team
Yeah.
doesn't sleep.
Yeah. So I think that we can get a bit started maybe with engineering updates as usual. We'll
Yes,
get
I
like
was
some
going to
news
ask that.
from Mauro, and then we can talk
Yes.
on other topics.
All
Mauro?
right. So on the engineering side, like we are working as the last weeks in two fronts or three. One on the platform for CK Gaming. We finished the first. I mean, we finished a complete version. I think that will also help as an example of how to use Line. We run some playtests with people, and we are getting their feedback and doing some improvements with that feedback. And also adding some missing screens, like more related to Align, so the user can have like a good way to withdraw funds, for example. For those who haven't used Align yet, like you deposit some funds, you use that to pay for proofs, but then you might want to withdraw them. So we are adding that. Like you could do it through the terminal, for example, but we want to give a front end to do that, and a couple of other missing things. But the flow is already working. Then we are still working as always a bit on the verification layer and doing some improvements like stress testing adding some more stress test to the network, improving reliability. Most of the parts of our infra has redundancy. We were missing like just one little part, and we just added it. Yes, and some other small improvements that we saw that might make maybe some operator miss a task. It's usually not a big problem because as long as the majority agrees on something, is good. But we want to improve it a little bit more and try to get 100% of the quorum most of the time. Then on Etrex, we're working a little bit with Etrex with the Etrex team to start running some benchmarks on proving times and have some better idea of like some capabilities of the network. That will allow us to make some design decisions on how the L2 ecosystem should be configured, like and set. It's not a big deal on the engineering side, but having more data allows you to better fine tune some constants or some variables of the system. And that's on the engineering front. I don't know if you have any questions. If not, like we can continue with another topic.
No, not on my side, but Boris.
Yeah, I just wanted to say, so I mean, to summarize what you said, Mauro, for people who are following and tracking what we're working on, I actually, RJ, I'd love to get an explanation for everyone on ZK Arcade in a second, but Mauro shared progress on that, as well as updates on the proof verification layer, resiliency of the system, stress testing, and then work with Ethrex on benchmarking proving for the client, which, just to make sure people understand, that is the core part of our ZK rollup as a service platform, which we are launching and already have some users like Savra set up to use. So a lot of progress on multiple fronts for our products. But I think ZK Arcade is something people would like to hear more about. And RJ, I think you'd be the best person to share a bit about what that is, because I think the community will be excited once we have something to share.
Yes. So regarding CK Arcade, what we're doing right now is creating like an application from our side, showing what it looks like to be on top of Aligned. So the idea is to have like an arcade-like platform where you try multiple games. All of them are provable. What it means is you run them in your computer, either in the browser or directly in the terminal, and you prove that you actually achieve or you did certain things with certain movements on the game, and you achieved certain levels on the game. So the first one that we have is called Beast, and the idea is people that played on their terminal, and they can send them later a proof directly to a line showing that they completed until a particular level with X amount of points. So we'll show why and how we're going to use Sick Arcade for other parts of our program and roadmap. But I think it's going to be fun for people to be able to actually use CK for something and to use directly a line for someone that is not technical. Because so far, the people that we have tried Align are developers in hackathons. We did many of them last year. And what we're trying to do is offer something for normal people to be able to test Align. That is the kind of like the difficult scenario usually in B2B like infrastructure projects like us. So that's it. We will share a little more of our plans behind Sig Arcade once we can. And the last thing I will mention, Mauro, is for example, for Beast, that is the one that is already working. Is working with SP1 and Rig Zero, right? And then the other thing that we can say is the other games will be one with Circom, uh, that will be run directly on the browser.
That's right.
Yeah.
So we will, that way we can show that the multiple brewers and how they integrate with the line. And it's also a good example for developers that want to do build other things. Because I think this is the first time, like leaving aside some small project from hackathon, that people will have like a full project with everything that needs to have to run on Ethereum.
Yeah, it's very cool stuff. As someone who got to test out the demo already, it's one of the things we talked about, during our hackathons last year. The idea of verifiable games, provable games, which is like with zkVMs, this is something that has been unlocked. Like a verifiable on-chain leaderboard, very cool idea. People who are into gaming, you can imagine how provable results could be important for anti-cheat and like making more fair games and connecting that to maybe programmatic payouts, for example. Lots of cool ideas. So yeah, excited to share it with everyone once it's ready, which I guess should be soon, but I don't think we'll give a date yet.
Yeah, exactly. But we're gathering local internal feedback in terms of the UX and if things are working smoothly, and then we'll see what we can share. And then the other thing is, for some of these games, if we want them to run in mainnet, we need to upgrade the proof verification layer, right, Mauro? So that's something that we will do soon, so we can add Circom directly.
Yes, we still need to upgrade mainnet, so that will be done in a couple of weeks. We were delaying it a little bit just because we are shipping many upgrades every week. We were waiting to have like a bundle with everything. But yes, if you're building something on Circom, you can already use it on testnet and will be soon on mainnet.
Okay, yes. So I guess that's it for updates. But Mauro and Diego, you guys you were talking about some interesting new research developments that you wanted to discuss, and I'm excited to hear about.
Well, there are a couple of things actually going on. As always, you have improvements either on the protocol side or on the security. For example, in the case of Starks, there are a couple of conjectures that you can use to determine security that will allow you to, for example, work with a smaller number of queries, which results in smaller proofs. But the problem is people say, okay, but you are relying on this, which is not proven. It's just something that you conjecture, and that makes things a bit difficult. Of course, the problem you have is if you want to work with the current bounds for provable security, maybe uh, you are using a lot more than you need, and really you are targeting a higher security level. Okay. Um, so of course there are like a couple of things that remain to be solved. In general, you have like some bounds up to a given level. Um, but it's interesting that apparently uh, the problem of mutual correlated agreement up to the Johnson bound has been solved. I think once we see the proof and everything, uh, it will be something really good because it allows us to understand better what's going on under Starks and shows that some of the conjectures that were used are actually valid, and that boosts confidence. Besides, it's evident that hash-based proof systems have been um, gaining a lot of popularity. In fact, Ethereum wants to migrate to a post-quantum setting, and also like to greatly simplify all that is related to its consensus layer and everything to make Ethereum like leaner. Um, and if you want to have something that is post-quantum secure, then hash-based proof systems seem like the logical choice, as well as maybe using hash-based signatures, because elliptic curves rely on the discrete log problem, which is something that quantum computers, when they are ready, could solve very easily. Whereas solving like the hash-based problems are like way more difficult. Quantum computers reduce the security, but it's easy to get like the previous security level just by um, increasing the size of the digest. So that would make like signatures or proofs like longer, but it wouldn't be something as catastrophic as having all your curves completely broken. So of course, having these advances in these bounds and conjectures is important. We hope that we can arrive at some point to um, a better bound for the number of queries that you need in hash-based proof systems to get the security that you want. So that was one of the things that um, was interesting to know. Of course, the paper will be, I hope, coming soon, and we will be able to discuss it at some point. Um,
I think like this all comes with a big push from the foundation that is also like putting some bounties on many things. It's like I don't know, people. There is a lot of people saying, okay, this hash function might be broken, and now it's like, okay, you can break it, like we pay you. The You can make a demonstration of the security of Starks, like there is a bounty for that. They are putting a lot of resources on improving the security of these protocols, either on on the theoretical front and on the applied one. It's like, so now game's on. Like we will see where it leads, but now there are incentives to start either breaking things or showing that you cannot break them.
I guess so. So you mentioned that the foundation, like the Ethereum Foundation, has some of these grants, and I think these are the ones that are listed on the Lean roadmap, like the Lean consensus roadmap. Am I right about that? Like they have a bunch of research tracks listed. I can share the link or even share my screen. But Poseidon Cryptanalysis Initiative, hash-based multi-signatures, minimal
yeah.
Falcon, yeah, okay, Falcon signatures, all that stuff.
Okay. Yeah. The idea in this case of using Poseidon is because um, you can prove more Poseidon hashes per unit time than using Keccak. Of course, Keccak has been around for much longer. So far, there are like no known attacks to Keccak. Um, and so, while people want to know, okay, is this new hash function based on this um, arithmetic thing secure? Why? Because if we could prove that it's secure and everything, and there are like people have tried breaking it and aren't able, then we could like get an efficient like signature scheme using hash functions that you can prove very fast. Okay, the idea with these signature hash functions is basically something like uh, the public key and the private key are related by hashing. Okay, so you have your private key, and what you do is you hash it a lot of times, and the last hash is the public key. Okay, and so when you want to sign you don't have just a private key, you have like several, because you're going to chunk your message into several chunks. And what you're going to do is then interpret each chunk as a number, and that's the number of hashes that you have to apply to get like the value that you need for the signature. Okay. And the good thing is that then you, as the verifier, can check, because you know, okay, this corresponds to hashing, I don't know, 60 times, and the public key is hashing 256 times. So if I hash 196 times, I should get to the public key. Okay, and you do it for each chunk, and that way you get a signature. Of course, for this to work, you need something that when you encode your message, it should be incomparable with other messages, meaning that given two messages, each should have at least one component that is smaller than the components of the others. That is to say, no message is entirely larger component chunk by chunk with another message, because that way you could forge signatures. Okay. But this is interesting because then it means that the only thing you need to do is encode the message and then hash a lot. And if you come to think about, a signature is maybe thousands of hashes. But so far, benchmarks show that you could prove maybe 1,000,000 Poseidon hashes per second with a GPU or something. So that allows you to combine lots of hashes. Of course, one of the problems that remains is, how do you ensure that this proof is sufficiently small? Because maybe it's small, but maybe it's 1 megabyte and you'd like it to be way shorter. One could say, well, use CROT16, but the problem is CROT16 works with elliptic curves, so that is forbidden. And so you need to work a lot more with Starks and see how you can further compress proof sizes. For example, you have where, and where achieves like better bounds for security. You need fewer queries by doing like several clever tricks. So we still have to see whether there aren't any further ways of like reducing proof sizes and also making the proving process even more efficient, so that this can be run essentially on any computer, which I think is something that is desirable in terms of the decentralization of the protocol, because that means that anyone could perform these signature aggregations. So that's why it's important to do a lot of more research on the security of the hash functions, see whether you can arithmetize in a more efficient way, or improve your proof system to reduce proof sizes. So I don't know, it's interesting because there is still a lot of research. We know that at least for general purpose RISC-V VMs, there has been a lot of progress, and we already know how to make efficient VMs. But in this case, what we want is to have even that something that is more efficient, so that you can run it even on a simpler computer, and you can achieve maximum decentralization. In the case of your blockchain, maybe you don't care if you rely on a prover network or on somebody with GPUs to generate the proof. But here, maybe you really want this in terms of decentralization.
So Diego, to summarize for people who aren't as deep in the weeds around all the cryptography, all of this is important for Ethereum's roadmap, and different products built on Ethereum is sort of the high level thing. Post quantum security, improved decentralization. Is there anything else you'd add about that? Like, why? What kind of impact would this research have on this infrastructure and the blockchains we use?
No, I think it simplifies a lot all the design and everything, and it makes it like more resilient. The problem in general with blockchains is that in order to achieve verifiability, you had to re-execute lots of things. So by changing to something where you just verify CK proofs, uh, you get a much simpler design, because then you don't have to have everybody re-executing everything. You just have to verify proofs. So I think we are going into a future where CK is going to be an integral part of everything. And I think this will also mean that if you want to sync with Ethereum, it will be way easier, because you would just download like the latest proof, and you'll know that you are in the correct state and everything. I don't know. You had, for example, the case of Mina. Mina worked by um, generating this proof that the previous state was correct and that the transition to the next state is correct, and that way, via recursive proving, you get a proof that the everything is correct since the genesis block. Okay, so I think this increases a lot the security, and um, facilitates a lot of things in terms of user experience, state management. Um, I don't know. I think it's really cool that um, this will, I think, simplify a lot of things in the protocol, because you will just have like everything will be like CK, and then you can like run things off chain and then submit proofs on chain, and you don't have to do like the heavy computational part on chain. I don't know what you guys think.
No, I have a question actually, because now that you were talking about all of this in Mina, the proof also has a consensus, right?
Yeah, but I think that when you receive the proof in Mina, at some point you had to prove uh, the consensus separately, or at least show that.
So it's not okay. So you have a proof of the state transition function, but you need a different proof for the consensus.
Yeah, or at least show that it was included in the longest chain, because you have the problem of how do you know that,
Yeah, exactly.
because you know that the proof is valid, but how do you know
If
that
you're
it is
watching
actually
the correct,
uh,
yeah.
in fact, that
Be-
was a problem that we had in the Mina bridge. uh, and one way to solve it, because I could send you a proof of a previous state that was valid, and of course when you verify, you know it's valid, but you have to verify that somehow it comes like later, and that it's included in like the latest and longest chain. Um, but the idea was, okay, when you're verifying, you could also like verify the consensus and do all the checks related to consensus, and then you don't have that problem.
one last comment about this deal. So in this case, you with what you were talking about, you should be able to also use this proof because you're proving the aggregation of these signatures. Does that translate to proving the consensus? Meaning, with that, we will be able to just have one proof that we can use in other chains to prove the latest state as well? Or is there anything else missing?
No, I think you could, because the idea is that this signature scheme is stateful. So the thing is, when you generate like your public key, you can sign up to n messages. Why? Because every time you sign, you kind of spend a collection of private keys. Okay. And so the idea is that if at some point you had like several signing some message, they were using their keys number M, and in the next state they would have to use their keys n+1. And the good thing is that since in the consensus you only have to sign one message per block, um, this signature scheme works. It's a bit less flexible than current signature schemes, for example, what you have with BLS. But I think this is not a problem because of how consensus works in the end. So that's why they ended up choosing this hash-based option over others that you could have. But again, maybe I am missing like something.
I thought Mauro, you wanted to say something.
No, I mean we can continue that, but I don't think like verifying the signatures gives you enough information in our chain to do this, to what you want to do. So for me the answer is no. It's like you can verify the signature and you can know like who signed it, but how are you going to know like if the signer set is fine? Like unless like you have already snarkified all the chain, like you don't know if people went in or out. Right? So you will need to make like a very big aggregated proof of aggregated signatures. You might be able to do that through that, but just with one, you're missing information.
You don't know if they're still part of the quorum. That's what you mean.
That's right. Like there is no way to ensure that the quorum is there. So maybe under some assumptions, maybe if you assume that the main signers are always the same and you check for them, and maybe you say, okay, if the ones who have been signing this for 3 years are still signing it and they always have like most of the quorum, it's probably right. But
Yeah, the only
you are
thing,
missing a piece of information.
yeah, the only thing is that people will eventually have to switch their keys from time to time, because at least if they go with these signatures, they have to refresh keys, because at some point you run out of the number of messages that you can sign. Um, it has like some difficulties, but on the other side, the signature seems quite straightforward. Um, we may write something about it. I think it would help like understand a lot um, where Ethereum is going, um, and understand like the importance that CK technology has, not only for this for blockchain, but also, for example, for AI. Um, I was reading this book Genesis by Eric Schmidt and co-authored with Kissinger, and at some point they were saying like, and how do you know what the black box, meaning the AI, is doing, or how it is it doing what it's supposed to be doing? And it's like, well, at some point, if we could use ZK to prove inference, it would be like massive, because then you don't have to trust really that it is doing what it's supposed to be doing, because you would have a cryptographic proof that binds it to the prescribed program and set of parameters. So I think ZK eventually is going to um, reach other places, and if we can get to prove AI, then it's going to be huge.
Yeah, I think it will happen. Like I don't see why it will not happen in the next decade. Like uh, computers get better and CK gets better. I think it makes sense. Um, and I think the good thing about CK in general and the roadmap of Ethereum is that it's realizing that this tech is already working and is performant, and it simplifies everything. That you can redesign many of the things and make it even simpler, easier to understand for someone that is new, easier. Well, I'm not sure about this part, maybe you guys don't agree, but if the whole protocol in itself is easier, it should be easier to audit by someone external that is not from Ethereum. And by making everything more verifiable, it should make things more resilient. And that's usually what we want to achieve. And also
Yeah,
scalable.
yeah. I think it would also like simplify a lot, maybe the clients and everything, because at least Ethereum would be kind of the source of truth, and you have just to verify CK proofs. So I think then the logic becomes way simpler, and you cannot fool um, the nodes because you always have proofs.
Um, for people watching, you're getting a little taste of the kind of conversations our team has about cryptography and protocols.
Well, yeah, we have to talk from time to time and try to explain. Then, of course, you can go and read other places, but at least you know what are like the conversations that people are having.
Yeah,
Because, okay, we have Ethereum now, but we have to be ready for lots of things that we still don't know that could happen. Uh, and also like start like doing a redesign knowing, okay, now CK is a technology that works really well, because maybe in 2014 you had CK, of course fewer people understood CK, so it was maybe like, okay, I'm not going to try to create something entirely new like a verifiable computer and add this cool technology but which is super slow, because then UX would have been like the worst thing ever. But now that, okay, we have something that is getting like way faster and that it simplifies lots of things, it makes sense to uh, trying to improve the protocol and also prepare for some of the threats that we are facing. I don't know. The other day I read that Microsoft was already working on their quantum chips, uh, the Majorana chips. Um, so I don't know. They said like, okay, AI was coming many years later, and it seems it's coming um, faster than expected. And quantum computers, they've been saying that they are coming for some years. They haven't come yet, but you never know if it's going to happen really soon, and you'd better at least be prepared for that.
I yeah, I mean, maybe it just takes a couple of breakthroughs for these things to become feasible. I think something interesting one day in the future would be to hear your thoughts on what the major advances in ZK were that got got us to where we are today. Like, I feel like we should do a separate stream, like ZK history, um, talking about the
Oh
the
yeah,
big steps that really accelerated things.
yeah, because it's really funny that people knew like the Samcheck protocol from 1992, and it wasn't until like a few years that people started building really efficient protocols from the Samcheck. Um,
I guess there was Groth 16 in 2016.
yeah, but Grot 16 doesn't use the Samcheck protocol.
Hmm.
Uh, it uses a linear PCP. It's something else, but if you look, for example, the idea behind Starks, I think had been in Ellie's mind for like longer. Of course, it was a matter of things getting into place. I think that even if he had figured out things back in, I don't know, 2005, there would have been a very big problem, which was, okay, what's the use case for this? Um, of course, maybe, I don't know, if we had had Starks, then Satoshi could have said, okay, I am building Bitcoin directly with Starks, but I think that ZK benefited a lot uh, from blockchains because it provided a major use case, and blockchain solves lots of problems in the real world. And now we see that, okay, CK technology has advanced, and now we can move on to other applications. But I think the problem was like in the 90s, um, it was hard to think of a use case, because of of how the world worked. The internet was not as important in the 90s, especially in the early 90s, as it was in the early 2000s. So I think there have been like lots of changes in um, how we do things. And I think that with AI, it's going to be the same. There will be like some transformation of our habits, education, and we have to be ready for that. And I think ZK is one of the few tools that we have in order to keep in check AI.
Okay, I think we can do that, Boris. We can have as a guest. Oh no, we lost Diego. We can have as a guest Diego on a Wednesday stream, and you can talk about the history of CK. And if
Yeah,
Mauro wants to join as well. Um,
yeah. We'll have another class with Professors Diego and Mauro.
yeah, but I think we already are.
Yeah, 40
We already
minutes.
covered a lot today. We have 40 minutes of content. Um, so yeah, we can dive into more of this stuff later. But this up, yeah, we'll probably have more updates next week, and we'll be able to show. Probably Mauro will arrange a stage where we can show a demo. I will share from my account a demo from CK Arcade as well. It will be like the first version that we make public with a video, and it will probably change because the team is already changing a few things. But I think that's the other thing people can expect in the next few days.
Yeah. I just wanted to say, I mean, for people watching, wondering why we're talking about all this, I mean, we're building infrastructure and products for very long-term purposes, critical infrastructure, high value, applications of blockchains involving money. And all of the cryptography that we're discussing today is important for how we design these systems and continually improve them. So this is so you know that we're we're tracking all of this very closely because we're trying to build really good stuff that a lot of people will use and will use for a long time. So fast moving place, and we're lucky to have Diego and Mauro on top of this.
Exactly. Okay. Bye, everyone. We'll see you next week.
Thanks for joining. See you.
Thank you for
Bye
joining. Yes.
bye.
See
Bye
you.
bye.